Oh, it's on? Okay. All right, we're going to go ahead and get started here, guys. So this is the Rook deep dive for the Rook project here. My name is Jared Watts. I'm a maintainer on the Rook project, but we'll also be hearing the bulk of the content today from Tony Allen and Alexander Trost. So I think that a fair amount of you were probably here for the intro session we did a few days ago. So a lot of this content up at the beginning about what Rook is and why it may be important, I'm going to go through really quickly and not spend too much time on it. But I think there's a couple new faces, so it's hopefully worthwhile. So what is Rook? Rook can be classified or described as a cloud-native storage orchestrator. And so what that means is that storage systems, storage solutions, like distributed storage systems such as Ceph, if you want to deploy them and use them in a cloud-native environment, or like Kubernetes, Rook will handle that for you. And so the way it does that is by extending Kubernetes with some custom types and controllers to make a nice native experience for it. And we'll get into all that later on. So some of the specifics about how it works is that it does a lot of automation for you for these storage systems. The deployment, bootstrapping, configuration, scaling, migration, all that sort of stuff. It's handled with automated software to do some of those tasks for you. In addition to that, this is a recent thing too, that Rook can be considered a framework for other storage providers or storage types to also be integrated into Kubernetes. So it's an open source project with the Apache 2.0 license. We open sourced it about a year and a half ago, and we were accepted into the Cloud Native Computing Foundation as a hosted project just in the last few months. So a couple of challenges that Rook's trying to solve. So one of them is relying on external storage. So you have a Kubernetes cluster, you've got storage needs. Most all the time, that storage is going to be provided from an external cluster. So that requires that those services need to be accessible. And it also creates a deployment burden where, if you have an application that needs storage, somebody's got to put that external storage, adjacent to your cluster so it can be accessible. A lot of times, often, you'll be relying on cloud providers' managed services for your storage, EBS or Google Persistent Disks, et cetera. And also other services like relational database, RDS, and Amazon. And so when your app starts taking dependencies on those specific services, you end up with vendor lock-in. You're less portable. And then another thing to worry about is having the storage all set up, that's good, but what about day two operations? Someone's got to manage your storage over time. And we'll get into a lot of that later on too. So a couple of different ways you can solve this that Rook's trying to solve is bringing the storage into the cluster, have it be part of Kubernetes. Once it's in Kubernetes, it's very portable then. You can, wherever you're going in Kubernetes, Amazon, Google, on-prem, whatever, you can easily deploy, you can easily deploy your storage in as well. And another way is, having abstractions for your storage needs. Say an application wants to have a database or a message queue. If we can describe that in some sort of portable abstraction, then no matter where in Kubernetes you're going to be deployed, Amazon, Google, Microsoft, whatever, you can get that storage very easily. And so what that enables is a power of choice. You can choose where your app's going to go based on costs, what features are important, resiliency and compliance. And then kind of as we were mentioning in the last slide, that someone's got to manage the storage, right? So Rook looks to perform that automated management to make sure the storage stays healthy. And two quick things here to set some context for the deep dive is that Rook takes advantage of two different means for extending Kubernetes and providing experience. One is custom resource definitions, CRDs. We've been hearing a lot about this week, and that's basically a way to define new first-class objects in Kubernetes that the API server can store for you, manipulate for you, and they look just like any other resource. That's pods, services, daemon sets, whatever. You can make your own, right? And you can manage them using kube control as well. And then we heard about the operator pattern. CoreOS in one of the keynotes yesterday was talking about their operator SDK. But basically what an operator is that the user defines what they want, the desired state for their cluster, and the operator is automated software to make sure that happens, where it'll observe the cluster to see if there's any changes the user wants, or changes in the cluster, then analyze what the differences are between the actual state and desired state, and then act to make the user's desired state actually happen in the cluster. And then last point that, as we mentioned earlier, Rook is now a framework. It's not just a collection of operators and CRDs. It's now a framework to help other storage solutions, integrate their storage technology into Kubernetes as well. And there's a number of common things that you'll see there to help storage providers get integrated in. And I'm going to actually deep dive through a implementation for Minio that we just did last week. And Tony is the developer for that. And he is going to walk us through what it takes to bring in a new storage solution into Kubernetes.
Oh, I have this. Yeah, you should take that. Alrighty. So we are going to hand wave through some code. I'm not going to go too in depth into like all the implementation details, but I'm going to hit the greatest hits of implementing an operator. If you want to add your own backend, this will probably be helpful. So here's the object store CRD that we used to define the Minio object store. So some things to note here is that the group and version names in the spec field are used for the REST API endpoints created by the Kubernetes API server when you register this via kubectl create. And the kind is of type object store, so that was very creative. And then the actual custom object that we'd be creating once that CRD is registered would look something like this. I left the spec field kind of empty because we use that information in the operator inside of Rook to provision Minio storage or delete it or do any kind of operations that we need to for it. So we'll have access to that inside of our Go code. As Jared mentioned earlier, so these CRDs let us enable like a native kubectl experience for that object store type. So here's an example. I created that object store CRD you just saw, and then if you show get CRDs, you can see it, and then you can create the actual object store object and do things like kubectl get object stores and see that running. But it's not very helpful right now, right? I mean, if you get pods, there's nothing there, so it didn't really do anything. So we need an operator, and what it's going to do is it's going to register and kind of listen for events like creation or updates to the object or deletions and act accordingly, right? So what we would want to do is make this operator, when it sees an addition, perform all the steps necessary to actually deploy the service and make it usable. All right. So we'll revisit an object store object. I should call it something else, but so inside the spec, we added a bunch of things that are necessary to actually provision like a Minio cluster. So what's highlighted in red here are things that Rook already knows about. So we've created a framework that has these common abstractions that you see across all types of storage, right? We're always going to need to know about network information, right? We're going to want to specify like how much CPU or memory we need on various nodes, and we want to know how many, node counts to have inside of the cluster. And for simplicity, I left out a lot of the Minio specific parameters, so we're just using credentials at the bottom there, and that's all that is specific to Minio for this operator. Okay, so we'll start with a YAML to describe our Minio operator, and all Rook operators kind of follow this common format. We're going to want to know, what container are we going to use, right? You send the arguments into it, so Rook knows that, okay, I'm doing something with Minio. What am I doing with it? Operator. Okay, so let me act as a Minio operator when it spins up. And we can lump that CRD that was defined in the first slide into this same file. So when you do a kubectl create, it'll define the CRD, and then it'll actually deploy the Minio operator as well. But we need to do a few things, before that. We need to actually make a Docker file for this operator. So the base image in this Docker file is actually Ubuntu Xenial, and it's a stripped down, optimized version of that. So all it's doing is it's pulling down, a Minio binary from the website. It's making it executable, and then it's adding the Rook binary that's built. And we're just running that. That teeny /teeny there is so that we can capture interrupts. So looking at some Go code, we need to implement an object store structure that defines what we saw in those YAML files. So if you recall what those common Rook abstractions looked like, we have that here. So these are actual types that are defined in Rook code, so it's outside of our operator. But I had to define actual credentials here. So this is important. So the actual operator, we need to make a watcher that watches for adds, update, and delete events. We have our own handler functions that we're going to implement, and I'll show you what those look like later. But what's important to note here is that we're using the Rook operator kit to actually create a new watcher. And what that's doing is it's using a Kubernetes informer to watch for these events. And the informers kind of help prevent excessive polling on API servers and does local caching. Okay, so this is what our add handler looks like. The add handler's implementation is pretty simple. I left out a lot of the specific details because we're using client sets to actually deploy the stateful set and create the services. But this is the flow of things. Like this is all that's required to actually deploy a Minio server. All the information that we had in the spec, things like the networking information and the number of nodes and the credentials, things like that, that's all being passed into these functions, and we're just using that spec structure and the information inside of it to perform these operations using the client set. And then the update handler, so right now nothing's really implemented, but this is where a lot of the more complicated logics can occur. So if we're performing an upgrade or downgrade, when you do a kubectl update and it notices something like a version change in the spec, right, you can perform the operations necessary to do that. If you want to expand or shrink the cluster using like a replica count change, things like that would be performed here. So I'm going to hand it over to Alexander here, who's going to kind of walk you through what using an operator in Rook looks like.
So yeah, my name is Alexander, and I'm kind of taking you on the road of what an administrator has to do in point of maintenance, for example, and just tips in general, and also monitoring. So for the Ceph monitoring right now, we use the native manager module that is available. There are also dashboards available on Grafana and Chrome, which are linked in our documentation. I will later also show them, and alert rules will soon come. I just have to polish mine that I'm using in my private cluster. Yeah. Maintenance helpful tips. So you should definitely monitor everything, which is hopefully the default for everyone here. And especially for Ceph, you should look at the latencies. For example, well, in my setup, I have like taking the default dashboard, which I kind of opted for the Ceph manager metrics and metric names, has always on the latencies a warning in orange, because my hardware that I'm using, which I'm later showing, is not fast enough to provide the speeds in which those thresholds would be. So in general, it is a good point there to look out, to find an average value where you can say, so this is my default, which is normal for the normal load I have, and then see further if there's, for example, more load on the node, if it's going high, and there watch out for anomalies to not potentially end in OSDs having high apply latencies where the data is even is written to the disk, which can cause delays on the file system, on block storage, on object storage for Ceph especially. Yeah, as another point here, working alert rules, you should check that your alert rules are working. It is good to have alert rules, but if they don't work, obviously that's bad. Another Ceph-centric point here, the deep scrubbing and general scrubbing of OSDs. It is enabled by default in Ceph, but potentially, depending on the load a node has, it won't be executed. So you should probably, have an alert rule going like, oh, in 1 week there was no scrubbing, there is something wrong right now. Because what scrubbing partly does is verifying the data if it's still still the same from primary and the slaves, the replicas. Yeah. Now to the demo part. The specifications of the cluster I'm showing off can be seen here. I'm talking a bit about it. So the OS is a container Linux based, previously CoreOS. So the Kubernetes in general is deployed with a Tectonic installer, but I'm using the vanilla Kubernetes version, where you have a toggle to say, yeah, I want vanilla Kubernetes or the Tectonic stuff. As a container runtime, I'm running Creo, which is kind of a, well, drop-in replacement, depending on how you see it, for the Docker container runtime. It's pretty good, because at least I had problems with Docker, no matter which version I used. And the switch to Cryo kind of fixed all issues that I had container-related. Yeah. The cluster in general has 3 Kubernetes masters for the HA respect, and in total 8 nodes. So those 3 masters are also used for as a node. The hardware specifications, it's pretty desktop-grade hardware. So it's simply an i7, a quad-core i7, 32 gigs of RAM, 2 times 4 terabyte disk, with a 1 gigabit network interface. Nothing fancy there. It's no awesome Dell hardware with special NICs or anything. It's just kind of your, well, desktop motherboard you're getting. Yeah. So now some facts about the disk layout and kind of capacity you're getting out of this setup I'm running there. So the first disk has 1 partition for the OS. The rest is kind of going into 1 partition where I'm saving the data host path that Rook uses to save the config of, for example, monitors, managers, and everything else. But also as a data partition, which I'm using as a directory for the OSD to save OSD data too. The disk 2 is completely dedicated to an OSD, and it's kind of split into 3 partitions. For more on that, there's self-documentation out there for Bluester, and also in the Rook ends. So the raw capacity you're getting out there, if you're just, yeah, well, doing the math, you're getting about 46 terabyte, which is then in real with, you're not getting 4 terabyte disk, you're getting something like 3 point something disks. You're getting about 57 terabytes plus minus with overhead of Ceph in general, and yeah. It's pretty good for that setup with only 8 nodes, and yeah. I'm personally happy with it, that's why I'm showing it off, and yeah. So, we haven't thought that through with the microphone. We do? Thank you. So let me go a bit like this. So what I'm kind of just going over is what applications I'm running on my, oh, well, yeah. I should probably write correctly. So, yeah, let's.
Oh, I think I muted it too.
Did you mute it? No, that's fine. So if I quickly grant myself access to the cluster, kind of old style with that, I'm using certificates and IP firewall. But we're fine. And I now finally run the kubectl, get all namespaces pod. So is it good for you? Good. So one of the first things we are seeing here, especially to highlight here, are the Stolons. Stolon is an application from SoundLab, which helps you run Postgres in HA in your Kubernetes cluster. If you haven't heard about it, it's totally awesome. It's kind of helping with each failover. One fails, it's just switching to the other one, and everything keeps up. It's pretty good tested too. And what's cool in the latest version, it also has a native Kubernetes store support, which previously you had to use an etcd server in your Kubernetes cluster to store the state of the cluster, which is kind of a pain in the ass. Yeah. So I have a few Postgres running there. The keepers are actually storing the data. They have a block device under them because, well, you don't want a file system, for example, a CFFS file system for a database. What I'm also going into with, let's say here, Nextcloud. Nextcloud is also an application which in my case uses file system. Well, it's awesome to have 26 terabytes minus the replication there from earlier with the 57 terabytes. The Nextcloud there has two containers. The second container there is from, if you have heard about it, Appscode, the Stash program, or well, the Stash application. It's using Restic in a sidecar with magic, to put it like that, to take scheduled backups of your data. So I have, what I've created in my case, I have a mini-IO instance in the cluster where all backups are collected and have a cron job in Kubernetes which uses then SFTP to push the backups somewhere else. It's a bit hacky if you think about it. There are better ways. For my personal cluster, it's perfectly fine. Yeah. Other applications I'm running, you may have seen something like Confluence or Jira software. Well, personally running Jira and Confluence in my cluster to keep track of nodes and stuff. I don't have the money for a big license, so it's sadly not HA in that aspect, but the data at least under it is running in a CFFS, which the pod goes down, it's spun up somewhere else, and it's instantly getting the data again. Yeah, registry, good example of just a small Docker registry with a CFFS below it to, yeah, store the images. Yeah, GitLab, that's one of my favorites to show off. You may know, not to bash GitLab there, but you may know their license with, I don't know, $50 or so per month. You get the GeoHA feature. You kind of don't need that unless you need one of the other features if you go, for example, with something like that. At least I didn't have any problems until now. I have two instances running. They're both running from the same CFFS data. So what I'm always liking to show, let me spin up a new. Am I on the right one? Yeah, so this is my private GitLab instance, just where we have it. I also kind of collect all my manifests. I'm not too much of a fan of Helm right now, so I have all my manifests also in my GitLab, and that is important. So what I'm doing, I can just simply go here, and you see I have two instances. Go back and go scale. The completion to the help. The talk was awesome by Sweatley. So, stateful set, GitLab, replicas. Let's say I have 8 nodes and I have a node, not node affinity, but a pod anti-affinity set, so I can go to, let's say, go to 7. So if we now narrow it down to the namespace, so we see a new instance of GitLab is creating. And you can also see some other applications like GitLab CI runners, which are well natively using the Kubernetes API to schedule their jobs, which I can probably also show. And we should be good in a second. So I'll continue for now, but you get an idea of general, I can scale the GitLab in that point to just fit my needs of load right now. A special part to note here is that CFFS has locking as a feature. I think when I tried GlassCFS, it didn't have the locking as a feature, which in my case kind of caused corruption for applications that had something like a SQLite database running and, well, maybe I was using it wrong, but I had some fun with it, yeah. So it's quickly, still not online. Which screen is that? So if I, for example, I'm in this repo here right now and I see, oh yeah, my sub-project here, and I quickly commit the kubecon, let's keep it simple, and I push that. You also simply see the point of, pardon, my font size. You should, see in the CI CI namespace where I just simply run my CI jobs, for example, now that it's going through. And even though it's currently upscaling the GitLab right now. So that's kind of, so where do you have it? That's a good point here. And if I go here and just spam F5, it's still working. And the same for scale down. Sorry. If I scale it back down again, we're currently at, I think, oh, well, 3 instances in total already. No, I've already canceled it, but you get the idea that it is possible to simply, with SafeFS or general network file storage in that regard, especially with logging, in my case, to scale something like that. Pretty easy. So, let me continue with the walkthrough. So I told you about Nextcloud. Some may know Plex. Anyone here know about Plex? Let's put it like this. It's pretty awesome running it on a 26 terabyte file system. And to put it like that, collect data, or, well, you get the idea. Linux distribution. Yeah. Yeah, every minor release. So, well, next to, obviously, Plex running here. Again, databases in HA with the block storage below it. And one of the things I haven't shown off yet is, if I'm able to find it here quickly, this is, oh no, it's a service. Just a second, it's a project. It's a project, perfect. What I'm running is Elasticsearch with the block storage. It's awesome. Well, it's working for me to feel like that, at least at my scale, with collecting, I think, from, well, my 8 nodes, and generally collecting web logs from, well, a gaming community I help out with, and yeah, generally doing some log analysis there. And let's quickly jump in there. I'm not seeing anything. Oh, well, let's go here, logging, just so you see that it's, well, working. If it's finally loading, finally. So, you can see, I have 2 dashboards. Well, only I'm too lazy to create the dashboards in Kibana. So, to just quickly go in, you see log analysis on top of block storage, at least Elasticsearch on top of block storage. It's working fine. Yeah. Now that we are kind of cutting into logging / monitoring with that, if I, again, get the right URL, I'm finally going into showing you the SAF dashboards we have. So, okay, yeah. SAF. So if I remember correctly, we have the SAF cluster one. This is kind of the stats, by the way. So we have general stuff, IOPS, use capacity. This one's broken, I know. There's definitely more than 7% available capacity in the cluster. The throughput of the cluster, and what I already told in the maintenance, the latency should be kept in mind. And if you kind of see here, mine's orange because the hardware's, well, desktop grade, and if you have enterprise hardware, it will be definitely better. It should be better. If not, there's probably something wrong. Yeah. As I said, they're available on grafana.com. Quick look at the OSD one. We see how many PGs are per OSD, the latency, OSD storage, the utilization and everything. And for a pool, this is kind of a bit ugly. The template variable is not the name of the actual pool, but the number of the pool. I have to find a way to replace something there. Stuff on my to-do list right now. Yeah. That's kind of it.
Cool. So yeah. So what? To kind of to summarize everything there. We had sort of two different tracks for that deep dive. The first one, it was Tony showing off from a developer perspective and a storage provider perspective what it looks like in code, with the actual implementation of how a new storage backend or storage provider can integrate with Rook and be able to be orchestrated, deployed, configured, managed, all that sort of stuff into a Kubernetes cluster. And then it's a separate side deep dive with Alexander, with going into what it looks like from an administrator's perspective of, okay, cool, you've got Rook, it can orchestrate a bunch of storage for you and manage it in your Kubernetes cluster, but then what can you do with that storage? And so I've always liked looking at Alexander's cluster because of the number of applications he's running that are taking advantage of storage that's been orchestrated by Rook, block storage, file storage, all those types of storage underneath all of those, high number of applications that he's running in a actual useful cluster. So then, yeah, if you want to get involved with Rook, as an open source project, we love new contributors. If you want to, come get involved, we've got some issues that are, good for first timers contributing. Lots of things for help wanted. You can find us on Slack, Twitter, forums, and we have community meetings you can get involved with as well. And the last session that we have is my session this afternoon in the big auditorium 10 about Kubernetes runs everywhere, but does your data. So if you want to go check that out, that's at 14:45, 2:45 this afternoon. All right, and that's all. Any questions, guys? Yes.
What's your biggest priority at the moment in the Rook project, like going forward? What's your thing that you want to get done next?
Yeah, so the question is, what's the biggest priority for the project and what do we want to get done next? And I think that's really two things. We have been orchestrating Ceph storage since the beginning, since the very first day of Rook. And so getting the deployment and management of Ceph storage to a production ready is a high priority. Being able to do upgrades over versions with migrations during the upgrades and make sure everything's healthy. Automating all that and making sure it's as reliable as it needs to be for production systems. Alex is obviously a huge help with that, with all the load he's putting on it, and getting us some real world vetting. But that's a big priority. And then the other one is this whole framework idea of being able to provide the resources and tools for other storage providers like CockroachDB and Minio, Nexensa, all these guys. Getting that framework fleshed out in more storage providers, because the goal is to be able to integrate as many storage systems as we can, or as storage providers can, into Kubernetes. We want to get people into Kubernetes and be able to be useful in cloud native environments. So being able to help as many as we can is really the goal there. Second goal. Yes, Beer.
Ceph does provide object store. Minio does provide object store. Like, would there be like a standard way of saying like, I want a bucket for this user that would be compatible with Ceph and Minio?
Yeah, so the question's about both Ceph and Minio offer object storage, like an S3 compatible interface. And will there be a sort of a compatible way of applications asking for buckets and bucket storage? And yes, that's a good question. That's something that getting into that whole abstractions of data needs. When an application needs data, how does it define that so that it can get that request fulfilled from an underlying storage provider in a portable way? And bucket is a huge one for that, and database is another one, message queue. So that's definitely something that we're thinking about and really want to kind of have a common, consistent way as well. Yes. Oh, so the question is if you can use Rook to integrate legacy storage, iSCSI or SAN boxes. Really what Rook focuses on is orchestrating storage into the Kubernetes cluster. So legacy systems, or appliances that are outside of the cluster, there's no real story for that to kind of bring those into the cluster. It's really about containerizing and making portable storage solutions that can then be run as workloads within the Kubernetes cluster is the big focus there. Yes.
If there's a measurable performance difference between Rook and running Ceph on bare metal?
Oh yeah, great question. So the question is about performance differences between running Rook and then running Ceph on bare metal. And so we have done some benchmarks on that specifically. There's a blog post that we had done about it as well. So the key aspect is that when Rook orchestrates Ceph storage to get it up, deployed, and running, it gives Ceph direct access to the devices, so they can write directly to a block device without having to go through any file system layers or any indirections. So the performance was very comparable between on bare metal and not. And also, Rook works in on-premise bare metal environments as well. If the only requirement is Kubernetes, so wherever Kubernetes is running, Rook will be running too and can deploy onto that hardware. Excuse me, in bare metal? Is it? Yes, yeah, we actually have a cluster up and running. That's his cluster is bare metal. What we were looking at there is a bare metal cluster. What's that? Oh, nice, awesome, another bare metal cluster. And another hand too, all right. So that's a yes. It's a question?
Does Rook any optimizations in the data it has to handle in the code? So like merging write requests or something?
Yeah, so that's a good question. And so the question is about if there's any optimizations in Rook for performance or on the data path basically. Oh, we're about out of time, so I'll just finish this real quick. So the important thing to remember is that Rook itself is not on the data path. So Rook is about orchestrating storage systems to get them to run in cloud-native environments effectively, but it's not on the data path. So when you go to read or write storage or write a byte to a disk, that's going to go through Ceph or through Minio or whatever the underlying storage provider is, and use whatever the functionality and features they have in those storage systems will be what you get. Rook is out of the data path. Cool, and that's all the time we have, guys. So thank you very much for coming to the deep dive. Appreciate it.